Today we'll try and look at the differences between a composite number and a prime number. Before we start with just a quick definition, prime number, it's a number which is divisible by itself and 1, whereas a composite number or a whole number, it's essentially divisible by 1 itself and something else, another whole number. So let's just dig into the details that we have here. What we try to do here is to put a visual representation of the composite numbers and prime numbers. And the way we did that is, if you look at the matrix, we start at the top with the numbers like 3, 5, 7. These are all odd integers. So 3, 5, 7, 9, 11, 13, 15, 17, 19. You can keep going on like this. And then at the bottom, we started just listing out numbers going on a consecutive basis. So under 3, we have 1, 2, 3, 4, 5, and then under 5, we start one number down, and then we go 1, 2, 3, 4, 5, 6, 7, and then same thing on 7, we start one number down. So it creates a matrix. And then under each one of them, under each column, let's say we're looking at at 3. We highlighted multiples of 3. So we have 3, 6, 9, 12, 15, and so forth, and those are in blue. Then we start at 5, and then we do the same thing. So 5, 10, 15, 20, 25, 30, and so forth. Then we start at 7, and we start with 7 as a number, the first number, then 14, then 21, 28, 35, 42, and so forth. After you go through all of this, then we put a trending, which the trending is that on 3, for the first column, we start at 3, and then we create kind of like a triangle, and then same thing on 5. Now the difference is that when we start on 5, we actually start at number 10, and the reason why is because we're taking 5 minus 1 divided by 2, which is 2, and then multiply that by the number 5, which is in the column, and then it gives me the 10. So that is my breaking point, where you break this out in triangles. And so you can see that there is a certain level of ordering here. And so this is a visual representation, which I don't think it's been done anywhere else. I think this is the first place you'd probably see this, and it might be helpful. I mean, for anyone who's trying to figure out any type of ordering behind prime numbers, or, which I mean inherently are related to the composite numbers. And this could be a good visual representation as opposed to just looking at calculations. So each triangle, so if you look at the blue one, for example, under each row you'll have, let's look at 15 and 11, there are 2 blue items, right? So same thing when you go to the next one, which are under the 5 column, and you have kind of like a burgundy coloring here, and then we have the green one, and you can keep going like this forever, right? Like you can create this type of setup going forward. But let's just take a very simple example. Let's say we're trying to see if we multiply 5 and 11 gives me 55. How do I triangulate it back into this matrix? So 5 times 11, it's equal to 55. Another way to represent this is, if you look at the 26 here, you have 26 times 2 plus 3. And this is valid for every row out there, right? And the 2 numbers which divided are falling under the columns 5 and 11 in this case. So we have 5 times 11 gives me 55. Another way to get to it, it's 2 times 26 plus 3 is equal to 55. So every row that you pick here, you can calculate the number by multiplying it by 2 under the first column, plus 3. So if you look at 21, like 21 under column 3, you multiply that by 2, which will give you 42, plus 3 is 45. And 45 is actually divisible by 3, is actually divisible by 5, and then it's actually divisible by 9, and then it's divisible by 15. So you can see that all those divisors are actually showing up in this matrix very easily. And you can get to that number 45 with different, like, multiple ways. But you can see that we looked at 5 times 11, which was the 55. Then we picked another number just for the sake of like looking through it, the 21 in this case under column 3, and then we saw that there are the 4 divisors here. And so this is very helpful. I mean, there is a certain ordering which you can figure out, like how to triangulate back to the original numbers. And what you're going to get out of this is that if you look at row 17, there are no highlighted items here, right? Based on the matrix and the ordering that we set this up, there are none, which means that if you multiply 2 times 17, which will give you 34, plus 3, which is the same calculation, is 37, and that's a prime number. So that's telling me that every row here which does not have a divisor will eventually give me the prime numbers. So this is very helpful for someone who's in mathematics and is trying to figure out a way to find some sort of a trending. So this will give you a very good visual representation, and it shows a certain level of ordering. So if one is ordered, the other ones might be ordered as well. So if composite numbers are ordered, then prime numbers should as well. And this thing has, I mean, in the past they've indicated so through various mathematical formulas and so forth, but this is that visual bridge that will help you. And that ordering, I mean, you can see in this case, if we pick up column 5, you'll see how this is set up. It's set up like a triangle, a 90-degree angle triangle, and you can keep dragging this down, and you can keep doing the same thing. So I think hopefully this is a good kind of matrix for you to view, and for anyone out there who's doing any sort of mathematical computations in terms of trying to find some sort of a trend in terms of how prime numbers are distributed, this could be helpful. So I thought we would put it out there, and next time we'll keep going with additional matrices which will be helpful in building out prime number distributions. Thank you.